This lesson is about measures of central tendency. In mathematics, when we have a set of data, we like to summarise the data with an average or a typical score. There are three ways that we can do this: the mean, the median, and the mode. All three of these indicate the location of the data and can be used to represent the average or a typical score. To calculate the mean, all of the data points are added together and then we divide that total by the number of data points. So this symbol here, x bar, is used to represent the mean. Sigma means sum of all the scores divided by n, the number of scores. Now if you get a calculator and check, the sum of all of these scores is 233, and there are 10 scores, which gives us a mean of 23.3. Now we're going to see what happens if we add an additional score to the data. So if we add a score of 97, we now find that the sum of the scores is 330 and the number of scores has increased to 11. So the new mean is 30. Now remember that the point of finding the mean is to summarise the data with a typical value. The 23.3, even though none of the original values had a decimal part, can be said to represent a typical value in the data. Now the mean is 30. But if you look at the original set of scores, none of those is above 30. But bringing in this additional score of 97 significantly increases the mean. We say that this 97 is an outlier and it alters the mean significantly. The median represents the middle value of a set of scores. The first thing we need to do when calculating the median is to put the scores in order. Once we've done that, we can work from the outsides in to find the single value located in the middle of the data. What happens to the median if we add an additional score of 13? Now when we work from the outside in, we're left with two values in the middle. To find the median, we work out the number that lies in the middle of these two central values. We can do that by finding the mean of the two values. What we find with the median is that if the original number of scores is odd, then we have a single value in the middle. If the original number of scores is even, the median will be the average of the two middle scores. The third measure of central tendency is the mode. The mode represents the most common value in the data set. Sometimes we may have two modes, and then we say that the data set is bimodal and we state those two modes. In this data set here, we have 1 7, 2 8s, 2 5s, 3 9s, and 2 11s, and so our mode is 9. However, if we replace the 7 with another 5, we have 3 5s as well as 3 9s, and now we say that the data is bimodal and that the modes are 5 and 9. Now I would like you to pause the video and find the mean, median and mode of this data set, preferably without using a calculator. A final question might be to ask, which of these three measures of central tendency best represents a typical score from the original data set? Is it the mean, 3 2/15? Is it the median? Or is it the mode, which tells us that the most common values are 3 and 5? We're now going to consider some different problems involving the use of the mean. In the first one, we know that there are 5 scores and that the mean of the scores is 16.2. Now, if you think back to that earlier equation, the mean score is the sum of the scores divided by the number of scores. We can rearrange this equation to say that the sum of the scores is equal to the mean multiplied by the number of the scores. In this particular example, our mean is 16.2 and we have 5 scores, and therefore the sum of the 5 scores is 81. Similarly, we have the mean of 6 scores is 23.5, and so the sum of those 6 scores is 141. We're then told that 5 of those 6 scores are 17, 20, 19, 25 and 30. Now those 5 scores sum to 111, and so the 6th score must be 30. Now we have some information about 2 groups of students within the same class. The 15 boys scored a mean of 21.2, so the sum of the boys' scores, which is 318, and the sum of all the girls' scores, which is 224. The mean for the whole class is the sum of all of the scores divided by the total number of students. Therefore, the mean for the class is 21.68. Now notice that this is not the same as taking the mean of 21.2 and 22.4. This is what's called a weighted mean, and we need to consider the total scores and the total number of students and not simply take an average of the 2 averages. If we're dealing with a large number of data, it can be quite tricky to work out measures of central tendency. It's much easier to first put the data into a frequency table or a frequency diagram. So firstly we will tally, so 16, 17, 20 and so on. And then once our tallying is complete, we can write in the frequencies of each score. We could also represent this same information using a frequency diagram. So for each score, we place a dot on the diagram to represent the frequency of that score. So we have 110, 112, 2 13s, 4 14s, and so on, until the completed diagram looks like this. Organising the data this way makes it easier to calculate the 3 measures of central tendency. So firstly, the mode, we just need to look for the highest number in the frequency row, and that's 11, which tells us that there are 11 scores of 17 in the data. Secondly, the mean, if we were to go back to that original data, we would have to add up 16 plus 17 plus 20 plus 17 and then divide by the total number of scores. But we can speed up that process if we label the scores X and the frequencies F and multiply X by F, and so on. So rather than having to go 10 plus 12 plus 13 plus 13 plus 14 plus 14 plus 14 plus 14, we can speed that process up by multiplying each score by its frequency. And then N is the total of all the frequencies. Our mean is the sum of all the scores multiplied by their frequencies divided by the sum of the frequencies. For this data, that's 807 divided by 50. The mean is 16.14. And thirdly, the median, remember, is the middle value when the scores are placed in order. We've got 50 scores, and so the median is going to be halfway between the 25th and the 26th score. So if I work from the left here with my frequencies, plus 2 is 4, 8, 17, 27 scores are 16 or below. Between the 25th and the 26th score is going to be 16. And again, I would ask you to think about which of these measures of central tendency gives the best representation of the data. A stem and leaf diagram is a nice way to visually represent a set of data. It looks a bit like a horizontal bar chart, but it keeps all of the original data intact. However many digits are in your original data, the last digit is used for the leaves and the other digits are used for the stem. In this particular case, we've got 3-digit numbers. The first 2 digits are used for the stem and the third digit will be used for the leaves. Our first value is 139, and so this is represented on the diagram. The 1 and the 3 are already on the stem, and we just add the 9 as the leaf. 168, we already have the 1 and the 6, and we add the 8. 142, 133, now we already have 139, so 133, we just need to add the units digit of a 3 there. 152, 155, and it's important to make sure that these columns all line up. There are no commas, there's no symbols in between, but it still needs to be a very organised diagram. And if you've got squared paper, it's even better because you can put each digit in one of the squares. It's not quite finished because in the final version of the stem and leaf diagram, each of the leaves is placed in numerical order. Instead of 931, it's 139, and each row of leaves is put into ascending order. There's one final bit of information we need, which is to add a key. Without it, this 127 could be 12.7 or 1.27, so we need to say that 12.7 equals 127. Now, if the data is in a stem and leaf diagram, to calculate the mean, it isn't much of a benefit. We still need to add up all of the scores and divide by the number of scores. However, to spot the mode is easier than the list of original data because we're looking for repeated values. And we can see that we have 3 155s, so that's the mode. The stem and leaf diagram also can help us to spot the modal class. Because we've grouped the data in tens effectively, the modal class is 150 to 159, and that's just the stem with the most leaves. And thirdly, the median is the middle value when the data is in order, and a stem and leaf diagram is in order. So we can work from either end, crossing off values, or we can realise that with 20 values, we need to be halfway between the 10th and the 11th value. So if I cross off 9 values from either end, my middle 2 values are 151 and 152, and so my median is 151.5. And again, I would just ask the question, which of these is the best measure of central tendency to use? The mean. Finally, I would just like to demonstrate how, with a calculator capable of performing statistical calculations, such as a ClassPad, you can save a lot of time and effort with computing measures of central tendency. If you have a statistics application on your calculator, type in these data and then select Calc, and the first option is one variable. The calculator will then list lots of useful bits of data. Firstly, X bar, the mean. We also have the sum of the X values, N, the number of values, and scrolling down we get the median, and the calculator lists all of the data as modes because the calculator doesn't have the facility to say no mode, it just lists each one. But if you change the data so that you've got 2 33s or 2 19s, it will list that single value as the mode.